Alrighty, we are back again. Practice test yesterday went up 3 points from that. And this was like, I should know these. So acid bases part one's this. We're gonna cover the two basic definitions of them, and then just some things to remember, things to know, have in the mind brain bank come test day, which is 2 weeks to the day actually. So dope. But let's just jump right into it. So definitions. We're going to have Bronsted-Lowry, acid bases, and then we're also going to have Lewis. Wow, I can't spell. Acid bases, and these are just super simple definitions. But Bronsted-Lowry, we're going to be thinking of protons, H+ / proton donors. And then since these are donors, these have to be acceptors. And then little side note, this is just something for my TA days, but Bronsted-Lowry, you're going to have two products when you do this, because it's just the proton that's moving. But then Lewis acids are going to be electron pair receptors, and then bases are going to be electron pair donors. And this is going to be one product for these reactions. And I don't remember it just based on the names and the thing, but these are going to be like boron, something 3, aluminum, something 3, as the acids. Those were at least the two that my teacher that I TA for used a lot. Okay, and then just terms / equations / things to know. So we're gonna go first one, amphoteric, acts as both acid and base. Right, and then we're just going to use water for this. So this is going to be the self. I'm going to actually draw this out for you. I'll use a different color too, just so. Or two different colors, but so there's one water, and that's going to be our base water. And then we're going to have our acidic water. And when we add these together, since it can act as both an acid and a base, since it has both protons and lone pairs, the acid is going to donate this one, right? And then so we get H3O plus. That's not how you draw that. H3O plus, and then you're also going to get OH minus from that, because it acts as both a proton donator and acceptor. Cool. I'll probably be using those again. Then the next one is going to be polyprotic, and that means you have more than one proton to donate. An example of this is going to be H2SO4. That's one of our strong acids. We'll get to those later. But its first association brings it to HSO4 1 minus, right? Because it lost one proton. But then, under certain conditions, you can go even further to just SO4 2 minus. Right, cool. Now we'll do some equations to know. And we'll start with Ka, because that's kind of where everything stems from. So Ka is going to equal the concentration of H3O plus times A minus, so conjugate acid base, over HA, which is the starting acid. And then for Ka, if we have a high Ka, then that means we're going to have a low pKa, because pKa is going to equal the negative log of Ka. But low pKa's mean strong acids. Right, and that's super tested. At least in chem it was, but that's good to know. pK equals negative log of Ka. We kind of discussed that already. And then let's do the Kw of water. This is just kind of a constant to know. It's the Ka of water. It's also this, right? And that's going to equal 1.0 times 10 to the negative 14. 14 is a weird number when it comes to acid bases because it's important. But then this is also going to be equal to the Ka times the Kb of conjugate acid base pairs. And this is going to be at 25 degrees C. Cool. And then we'll go over to Mr. Henderson Hasselbalch. And this one is going to be pH is going to be equal to pKa plus the log of the base over acid. Right, that's useful. That's something that I just kind of picked up on recently and I've been using a lot. What else do we got? Sorry, I'm taking a peek at my notes over here. Got all those. Oh, pH plus the pOH is going to equal 14. And like I said, 14 is a weird number. It comes up a lot. And then I guess we can go into, I'll just divide that up real fast, and then I'll bring out my green marker again, because that, to me, is what acids are. And we'll talk about the strong acids. Green kind of feels like a toxic vat that I grew up watching cartoons with. And it was just kind of eat you away, but it was always like, oh, that's acid. Right, anyway, besides the point. We're going to have our hydrogen halides. So those are all strong acids. And then we're going to have HClO4, H2SO4, like we talked about earlier, and we're going to have HNO3. And these are all going to have a Ka greater than 1. Right? Yeah, Ka greater than 1. And then we will pull out our blue marker, and we'll go strong bases. And we're going to have group 1 hydroxides / oxides. Hydroxides are something with OH. Oxides are going to be O. Some group 2 hydroxides. And then metal amides. And then an amide is going to be an NH2 group.